this video, let's recall how we can graph a parabola when it's given to us in intercept or factored form. Let's begin with the example shown here of y equals the quantity of x minus 2 times the quantity x plus 4. And let's walk through some steps. So first of all, let's begin by finding and plotting the intercepts. And we have a new word for the x-intercepts now called the roots. And we realize that in order to find the roots, we know that y has to be equal to 0. And if that's true, in order to make the right side of this equation equal to 0, one of these needs to be equal to 0. But we have two options. It could be the first one, it could be the second one. So we can say that x minus 2 is 0, and it's also possible for y plus 4 to be equal to 0. So we would have an x value of 2 and an x value of negative 4. So if we were to plot those, we would have a sketch here of 2, 0, and down here, negative 4, 0. There are two roots. Next, let's find the x-coordinate of the vertex. So x at the vertex, we know, is the midpoint value between our two intercepts. So we can either, leapfrog and count inward because they're nice integer counting numbers, or we can just always find the average. So what I'm going to do is I'm going to show how to find the average by adding the two values together and dividing by 2. We would get negative 2 over 2, which means the x value of the vertex is negative 1. So, again, sort of approximating something like this. The x value of the vertex, this is an upward facing parabola, so I'm expecting the vertex to be down here somewhere. And the great thing is I kind of get two birds for one stone when I do this, because not only do I get the x value of the vertex as being negative 1, but I also get the axis of symmetry being x equals negative 1 at the same time. Next, we're asked to find the y-coordinate of the vertex. So if we want to know how far down this is, this y value, let's plug in negative 1 into the equation and see what we get for a y value. So y is equal to, we'll put a negative 1 where there was an x. We'll use brackets so that we always maintain order of operations. We don't leave out a negative sign somewhere. So y is equal to, this simply becomes negative 1 subtract 2, which is negative 3, and this becomes negative 1 plus 4, which becomes positive 3. So therefore, y at the vertex is equal to negative 9. And there we go, we can label it as such. Next, we need to find the value of the y-intercept. So we can kind of get a sense here just from sketching it. I might just move this one over a wee little bit to be somewhat to scale. We can get a sense that this parabola is going to look something like this. And again, it's a sketch, it doesn't have to be perfect. Okay, I'm going to connect it now with a solid line now that I have a rough idea of where I want to put it. How can we find out this? Well, at the y-intercept, we know that x is equal to 0. So same idea. What if we were to go back and do this calculation, but put in zeros instead? So just because of the sake of space, and because I can, I'm just going to do this. So the y value at the y-intercept would be 0 minus 2 and 0 plus 4, which means that we would have minus 2 here, and we'd have plus 4 here. So therefore y at the y-intercept would be equal to negative 8. And we would expect that would be a little further up on the y-axis compared to the vertex, given how we've sketched things. So that wasn't so hard. And then in the question, in your notes, you're asked to sketch all of this, and I sort of chose to do it as we went along. Let's do this again for a different equation. This time, let's look at y equals negative 2 times 2x minus 1 times 2x minus 3. Here's our future equation, and let's do the same sequence of steps. And again, I'm going to kind of plot them as I go as well so that I can see if everything is sensible. In order to find and plot the intercepts, again, we need to let, or the roots, we call them as well, we need to let y be 0. And when we do that, we realize that the right-hand side of the equation could also be equal to 0 if there was a value of x in here that would make this bracket equal to 0, but also if there was a value of x in this bracket that would make it equal to 0. So let's pull those two pieces out and see what that value would be. We can say 2x minus 1 is 0, and 2x minus 3 is 0. Let's bring the 1 to the other side so we get 2x is 1. If we divide both sides by 2, we're going to find that x is a half. No biggie, it's just that one of the roots is a fraction or a decimal. That's fine. Let's do the same thing over here. We have 2x is equal to 3, and when we divide both sides by 2, we would get x is equal to 3 halves, or 1.5. Okay? So if we're sketching this parabola, we are going to have intercepts here at 3 halves 0 and at 1/2 0. Notice that this is a downward facing parabola, so I'm going to estimate that the vertex is up in here somewhere. Of course, our next step is to find out what is that x value of the vertex. And in order to find it, we need to find where the middle is between 1/2 and 3 halves. You might be able to figure out that, hey, that's 2 halves. If you can't, you can use some simple math to do it. You can add the two intercepts together and divide by 2. So this comes out to 4 halves divided by 2, but 4 halves is just 2. So 2 divided by 2 is equal to 1. So there's the vertex. The x value is a 1, and of course anytime we get the x value of the vertex, we get a little bonus in that we also get the axis of symmetry is also going to be x equals 1. Next we need to find the y value at the vertex. So the y value at the vertex is going to be putting the x value in and solving for y. So let's do that. 2 times 1 minus 1, and 2 times 1 minus 3. So, solving inside the brackets first, we have 2 minus 1, would just simply be 1, and 2 minus 3 would be negative 1. 2 negatives multiply give positive, and 2 times 1 gives me a value of 2. And there we are. So now we can start to get an idea of what this parabola might look like. It's got a stretch factor of 2, so it's going to be a little narrower than our base parabola of y equals x squared. Okay, and now that I kind of have a rough idea where I'm sketching it, I'm just going to draw it in, smooth curve. Next, I'd like to know what is the y value right here where it crosses the y-axis. So again, I can use the equation. I know that at the y-axis, x has a value of 0. So the value of y at the y-intercept is just going to require subbing in 0 where x was instead of 1 where x was. Okay, so that's going to change some values. We're going to have 0 minus 1, which is negative 1, and we're going to have 0 minus 3, which is negative 3. So 3 negatives multiplied give us a negative value, and 1 times 2 times 3 gives us a value of negative 6. So we know that this point is 0, negative 6. And we're able to sketch the parabola with all of its key features. Some x-intercepts, a vertex, and a y-intercept. That's pretty cool. I'm going to pause this video here, and I'm going to do the next video separate because it looks at an entirely different skill set.